Okay, this is your bonus assignment to do a retake for the Chapter 5B test. I will make a key on the video, but I'm hoping you try it before you watch the video. Okay, question 1. What does electronegativity mean? Electronegativity, and you should write this down, is how strongly an atom can pull on electrons in a bond. So I'll write down an atom's ability to pull on electrons in a bond. The more electronegative something is, the better able it is to pull on electrons, okay? And those values are on your periodic table, which I don't think I can show you because I don't have this figured out. Bummer. Okay, they're on your periodic table. All right. What kind of bond is formed when electrons are transferred? So when electrons get transferred, that is an ionic bond, okay, and they get taken from the metal. Electrons get taken from the metal and they go to the nonmetal. So for example, if I have potassium fluoride, potassium has 1 electron, 1 valence electron. Fluorine has 7. The metal gives its electrons to the nonmetal. So that electron is transferred. That's an ionic bond. All right, what kind of bond is formed when electrons are shared? Those are covalent bonds. Sometimes they're shared equally, sometimes they're not. What is the bond called when the electrons are not shared equally? That is called a polar covalent bond because they have different electronegativities. And one thing is more able to pull on the electrons than the other. That's called polar. When the bond, what is the bond called when the electrons are shared equally? That is called nonpolar covalent. All right, so for example, a polar bond example would be this hydrogen bonded to fluoride. Fluorine is way more electronegative than hydrogen. It can pull on those electrons very tightly. It's got a value of 4.0, an electronegativity value of 4.0, and I'm hoping you have your periodic table out so you can look at this. Hydrogen's value is 2.1, so this is a polar bond because fluorine doesn't share those electrons equally. A nonpolar bond is we have H bonded to H. They are equally sharing those electrons. Nobody's winning the tug of war, so this is nonpolar. If it's polar, this end ends up being a little bit negative because the electrons are closer. That end ends up being a little bit positive, okay? So right here, we use electronegativity values to determine if a bond is nonpolar covalent or polar covalent. We subtract those numbers. If that value, the difference in electronegativity, is greater than 4, that is when we consider the bond to be polar covalent. If the difference in electronegativity is between 0 and 0.4, that bond is considered nonpolar covalent. Okay? All right. I really wish I had my periodic table here. I don't know why. Oh, there. I guess you can see it. I hope. I hope you can see that. Okay, so here's my periodic table. Here are some values for you. Right there, fluorine is a 4. Hydrogen is a 2.1. That's what I was showing you. So let's do some of these practice problems. Okay? Number 8. Let me see if I can manage this. As the difference in electronegativity becomes greater, does the bond get more polar or less polar? As this difference, this delta En, gets bigger, that bond becomes more polar. Okay, so let me show you what this means. Okay, so H to F is 4.0, H is 2.1. Here's the value, 4.0, 2.1. You subtract those from each other, and you get 1.9, okay? On the other hand, if we have a FC bond, C to F, F has an electronegativity of 4.0. C has an electronegativity of 2.5. Now, if I subtract those, I get 1.5. So 1.5 versus 1.9. I guess you can't see my paper. 1.5 versus 1.9. So this is more polar. All right, the next table, you can do this. Okay, I want you to do this and fill in the answers and show them to me. Okay, show me what you get. All right, I'm going to stop this video and continue on the next.